So what we're going to do now is I'm going to teach you how to do the whole balancing thing. I'll give you lots of examples, but we're going to go one reaction at a time. So there's 5 different types of reactions that we're going to focus on. Formation, decomposition, single replacement, double replacement, and combustion. So the first one we'll do today is formation. So formation reactions is where we have 2 or more reactants combine to form something new. So when we think about like a basic formula or just kind of like a guideline, I say, okay, we have X. That's not any single element, it's just say we have X as a compound or an element. And we add some Y, and we make something, say we make X and Y. Okay? So that's what a formation reaction is like. You take 2 or more things and you make one other thing. Okay? Just like what we did when we burned magnesium. We took magnesium and oxygen and made magnesium oxide. Okay? So, some examples. Now here, these are word problems that we have to first translate into a chemical equation. So sulfur reacts with oxygen, so this is a reactant, reacts with oxygen to produce a product. So now we have to apply all of our knowledge of making compounds to this. So sulfur, so you have your periodic tables out and ready to go. So sulfur is S, but it has to be something very special, 8. And what state is sulfur at room temperature? Solid. Very good. Then it reacts with oxygen. When oxygen is at room temperature all by itself, it needs to be O2, gas, to produce. Now this is a molecular compound because it's a nonmetal and a nonmetal. So I use this naming to put it into a formula. So SO, what does tri mean? 3. Now we don't know the state of this because it's not one that we had to memorize. So we can just, well, I actually know what it is. It's gas. So we'll put sulfur trioxide gas into the question. Because we don't really usually know that for molecular. Okay, so now what we do is we draw a line down the arrow. You write out the atoms of each thing on each side. So on this side we have S's and O's. On this side we also have S's.
Should we write in pen or pencil right now?
Pencil, yeah. Should always be doing this in pencil. Put a line in front of each compound for where we can write a coefficient. I'm just going to give myself a bit more space. Okay, so then you count how many atoms on each side. How many S's on this side? 8. How many O's? 2. How many S's on this side? 1. How many O's? 3. Okay. So now let's start with the biggest gap first. So here is S8 and here is S1. So how could I fix that problem? You can put an 8 in front of here. So now I have 8 S's. But how many O's do I have now? 8 times 3 is 24. So now I'm going to cross out the 3 and put the 24. Now, I'm purposely crossing out rather than erasing so that I can see what work I've done. Okay? So, pardon?
Follow your steps.
Yeah, you can follow your steps easier when you just cross out and write at the side. Okay, so now I have 24 O's. So then you look back at your O's. Well, how can I balance this out now? You can put a 12 here. 12 times 2 is 24. So then you go back and you kind of check, okay, I have 8 S's, yeah. and I have 24 O's. Okay, all good. Now it's balanced. Conservation of mass and matter has been applied. Thanks, Antonio Leviosa. Yeah.
You made it?
Yeah, that's what it said in our notes. Okay. You want to try another one?
So then how would you break the final then?
So-
As 8 plus 12 over 2?
Yep, makes 8SO3. If you just have it like that, that's good. To me, that's final. So in your workbook, I'm just going to give them to you already made, and you have to do the balancing. And then there's going to be some questions where you have to translate the words
Oh,
into equations like this. So let's try another one. Nitrogen reacts with hydrogen to produce ammonia gas. So nitrogen, when it's all by itself, what does it need to be? N2, right? You look at your diatomics, and what state is it in? Gas. Hydrogen needs to be H2 gas. And ammonia, that's nowhere on my chart. Yeah, because we had to memorize that, right? See, you got them all memorized now. You guys are smart. No, well, yeah, smart, I guess, could be a good word. Yeah. Okay. So see, I made you memorize those things so that now when you see them in here, you will know what to do. Okay? So now we draw a line down the arrow. We write what we have on one side and the other side. So we have N's and H's. We have N's and H's. So on this side we have 2 N's and 2 H's. How many N's do I have on the product side? 1. How many H's? 3. Okay. So at this point, you can kind of pick whichever one you want to start with. They both have a difference of 1. So which one do you think we should do?
So normally you do the one with the greatest difference?
Usually, yeah. But honestly, you kind of just start and see where it takes you.
They're evil.
Let's do the N.
Okay.
Might as well start at
Start at the top. I'm going with Carson here. Okay, so N. So we have 2 on this side, but only 1 on this side. So what should I do here? I can put a 2. So now I have 2 N's. But what I did, when I did that, now I have 2 times 3. I have 6 H's now. So now I'm going to go back to my H's to go. So now here, this is what it meant in your notes about finding the lowest common denominator to get a whole number. So between 2 and 6, what do I need to do? Like, what's the lowest common denominator between the 2? 6, right? So then how do I get the 2 to go to a 6? I put a 3 there. So that's what it meant by lowest common denominator. So then now I have 6, so my 2's, my N's are all good, and my H's are all good, so now it's balanced.
You can only multiply, you can't divide?
Nope.
Okay.
And you can't put in like 1.5 either, you know?
No decimals.
Yeah, no decimals, only whole numbers. Yeah.
When you do this, do you end up with 2 ammonia molecules?
That's right. So what this means is that you take 1 nitrogen molecule, you can take 2 hydrogen molecules, and they'll make 2 ammonia molecules. So that's what it's talking about. Because in order to do this reaction, you need that. And you know, people say if they're making actual products, they will need to take this into consideration. Okay? All right, let's try the next one. This is one we've already kind of done. So we take magnesium, magnesium reacts with oxygen to produce magnesium oxide ash. So magnesium is just Mg. When it's at room temperature, what state is it? Solid. reacts with oxygen, O2, gas, to produce magnesium oxide. So now when you do this, you have to keep in mind, okay, this is an ionic compound, so you think to yourself, Mg2 plus and O2 minus. You do your crisscross,
MgO.
MgO. So you're gonna have to like use that technique when you're doing this. And we put a solid because we know it's ash. Ashes are solids, they're not liquids, right? Okay, so now you draw your arrow, your line. We put Mg on this side and O's. Mg and O's. I got 1 Mg on the reactants, 2 O's. 1 Mg on the products, and 1 O. Put your space to put your coefficients. So what should I do?
2 in front of the MG.
I just had a question. Would you ever come across a formula where it would actually end up balanced in the beginning? Like
Yes.
you have-
It is, yeah. So there are equations, and you will find some in your workbook that they're already all balanced. So when something's all balanced, you don't have to put any coefficients in front. Good question. Okay, so when we put the 2 in front, we changed the oxygens, but we also had changed the magnesium. So then we need to look back and put a 2 here. Then our magnesium will change to 2's. So that's balanced, and that's balanced. So the rest of the notes, like we're going to do decomposition tomorrow. Okay, so we'll do just kind of 1 or 2 types of reactions a day.